All right, for my example 3 on the law of sines, I'm going to take a problem from the textbook that I use to teach precalculus, which is Larson's 6th edition of precalculus. This is the one. So my example comes from page 411 if you're someone who has this textbook, and if not, that's totally fine too. Cool. So a pole tilts toward the sun at an angle of 8 degrees from the vertical and casts a 22-foot shadow. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. How tall is the pole? So most of us, when we see a word problem, immediately shut down and think, oh no, I can't do this. I hate paragraphs in my math. The interesting thing about word problems is that disproportionately they're not asking us a harder question. They're usually asking us a pretty simple question, often even easier than the other problems we've done, but we just start to flip out because of all of the math. So this is a little hard in that I didn't give you the diagram. If you're given the diagram, it's usually much easier, but let's walk through drawing a diagram. We can assume that the ground is level, meaning horizontal, unless we are expressly told otherwise in general at this stage of the game. So I have some level ground, right? Okay, I'm bad at drawing level ground, but you get my gist, right? And there's this vertical right here, right? Again, terrible at drawing, but you get the gist. So, and somewhere over here there's a sun, right? Because the way sun works is that sun hits this pole, right? So I'm going to draw this pole. Sun hits the pole and creates a shadow, right? So here's my shadow, right? The pole is tilting towards the sun because it says tilts towards the sun at an 8-degree angle. And I know it casts a 22-foot shadow. So I'm going to put 22 feet down here. I'm going to use P for pole. You don't have to. What I'm told is that if I'm looking from the tip of the shadow up at the pole, I am looking up at an angle of 43 degrees, right? And I'm also told that the pole leans 8 degrees from the vertical, meaning vertical would mean a 90-degree angle, but I'm 8 degrees more, so this must be a 98-degree angle. So if we label everything that I know, I called this side P, which means I'm going to call this big P, right? Because the angle opposite a side, we always use the capital letter. At the side, we use the lowercase letter. I'm going to go ahead and call this dot sun, because that's kind of where I put the sun, which makes this 22 lowercase s, which also works on the whole it's a shadow level. And then I don't really think I need either of these pieces of information. I don't think I need this. Well, I'll need the 98 degrees. So we'll call it B for base of the pole, and I'll call this lowercase b. So let's make a list of the stuff that we know. So I do know big P. It's 43 degrees, right? I called that angle P. I don't know little p, and for the record, this is the thing I want, right? This isn't saying solve the entire triangle. This is saying find this one piece of information. Other things I know big B is a 98 degrees, right? I don't know little b, but I doubt I'm going to need it. And I know that I don't know big S, but I know that little s is the shadow, which is 22 feet. Now, at first glance, you might think, hey, I can't use the law of sines. I need a pair. And you're right, you do need a pair, and the only chance you have at getting a pair is the s's. But the trick here is the same trick we saw in example 2, which is that it's easier to first recognize that these sum to 180 degrees. So if you know that these sum to 180 degrees, you can take 180 minus the sum of the 43 and the 98, and you can find that this angle is, I think, 39, but we'll do the math to be sure. So 180 minus, if I add these together, it's a 141. The way I got that was I said if this was 100, then I would have a 143, but it's too shy of that, so it's a 141. So when I subtract 180 minus 141, I get 39 degrees, and there's the pair that I need for my law of sines. So here's the pair that I need for my law of sines, right? And the big thing to remember here is that you only want to find the thing you're requested to find, which is, in this case, the height of the pole that I called lowercase p. So I just need to set up this ratio once. I never need to find little b. It's useless information for me in this problem. So when I set up my ratio, I want little p. So little p over the sine of 43 degrees equals little s, which was 22 feet, over the sine of sine of 39 degrees, mea culpa, which is my bad in Latin for anybody that was curious. So when I multiply that sine of 43 over, I'm going to get that p is a 22 times the sine of 43 degrees divided by the sine of 39 degrees, right? Again, in your calculator, you don't need the degree symbol because your calculator's whole job is to be in degree mode in these situations. So I'm going to type in 22 sine of 43 divided by sine of 39 And when I do that, I get a 23.841 or 842. So I get that my P is 23.841 or 2. And then because this is a word problem with units, I need to make sure that my answer has units. It's feet. So the pole is this many feet tall. So 23.841 or 842, depending on how you round or truncate feet.